Dmitry Mendeleev was a Russian scientist, and he's generally given credit for the modern periodic table. He proposed the periodic law, which states that when elements are arranged in order of increasing relative mass, certain sets of properties recur periodically. Now, this probably isn't exactly how he did it, but in his time, many of the elements were known, and he was trying to organize them, because that's what scientists do. We categorize and we organize, and he was looking for some way to organize this information so it'd be a little more useful. So I imagine him taking like index cards and writing the element name and its atomic mass and other things that were known about it, and then arranging these. And he's trying to, what would be the best way to arrange these? So he tries atomic mass. They were able to measure the mass of the atoms. And so when he ordered them in order of increasing atomic mass, and you can envision just this long row of different elements, he found that periodically there would be properties that would repeat. We need a periodic table. There's one. So on the periodic table, you know, there's hydrogen, and then helium, lithium, beryllium. Lithium reacts, well, what would be the best one? Let's just talk about the noble gases. You could do it with any of these guys. But so lithium, beryllium, and you go through here, and then he comes to neon. Neon and helium have some properties in common. Both of them are gases at room temperature, and neither of them form compounds. Like, interesting. And so you keep going, you go through these guys, and oh, argon. Argon's a gas at room temperature, doesn't form compounds. Interesting. So he noticed that periodically there were these properties that repeated. And so he arranged the elements by increasing atomic mass. There were some gaps, though, because not all of the elements had been discovered yet. So he left holes in his periodic table. It was called a periodic table because he was arranging things so that these periodic properties lined up. He left holes, and he predicted that elements would be found, that they would be discovered eventually to fill in those holes. And they were. And he predicted their properties, like density and how they reacted with oxygen and different things like that. And he was remarkably accurate. Really, really fascinating. To me it is. Anyway, so that's the periodic table. So there are a lot of patterns in the periodic table, and we need to understand some of them. We can classify elements as metals, nonmetals, and metalloids. And this periodic table is color-coded, and we see that all these yellow ones are the metals, and the green ones up here in the corner are nonmetals. And then along this stair-step line, we have a few that are purple. And those are the metalloids. So our periodic table on the walls, and the one I'm going to give you for an exam, they all have that stair-step line. They're not color-coded, but they've got the stair-step line. So that line is the dividing line between metals and nonmetals. So if I give you an element like wolfram, tungsten, is it a metal or a nonmetal? Well, you got to find it on the periodic table. W. Where is it? Well, it's over here. W. Well, which side is that? Well, find an element that you know something about. How about iron? Is iron a metal? Yeah, iron's a metal. This whole side of that line, then, are metals. The other side, find something you know about. Helium or oxygen. Those are gases at room temperature. They aren't metals. That's where the nonmetals are. And then along the line are the metalloids. The exception here is aluminum. But you know what aluminum is like, right? You probably have aluminum pans in your kitchen. It's a metal, isn't it? So aluminum is a metal, but pretty much the rest of these that are touching the line, that share a side with that line, are the semi-metals or metalloids. So just some general properties of metals. They tend to be good conductors of heat and electricity. That's why we make cookware out of them, because when you put a pot on the stove, you don't want it to insulate your food from the heat. You want it to transfer the heat to your food. We make wires out of metal because metal conducts electricity well. Metal can be pounded into flat sheets. You can hammer metal, you hammer it long enough and it'll spread out and you can make a big sheet of metal out of it. You can't do that with a lot of other things, like glass. Could you do that with glass? No, just shatter and break, right? But metals don't shatter and break, so they have these common characteristics. They can be drawn into wires. The fancy word for that is ductility. They are often shiny. Now these are generalizations. There are metals that are not very shiny. This is an important one for chemistry. They tend to lose electrons when they undergo chemical changes. So metals tend to lose electrons, and there's some examples of metals. The nonmetals have properties that are not as consistent. Some of the nonmetals are solids at room temperature, like carbon and sulfur, and a lot of them are gases. In general, they are poor conductors of heat and electricity, and they tend to gain electrons. So the metals tend to lose electrons, the nonmetals tend to gain electrons. Examples: oxygen, nitrogen, chlorine, iodine. Then we get the semimetals, or metalloids. These are the ones along the zigzag line. These have mixed properties. It's like a humanoid robot. Isn't human, is it? But it's like a human in some ways. Metalloids are like metals in some ways, and they're like nonmetals in other ways. They're also called semiconductors, and that's probably a word that you have heard of. Semiconductors are very useful because they have an electrical conductivity that is less than metals, but more than nonmetals, and it can be changed and controlled. So you can do things to a semiconductor to cause it to conduct or cause it to not conduct. And that's why semiconductors such as silicon and germanium are so important in making computer chips. Okay, so classify each of these as a metal, a nonmetal, or a metalloid. S, nonmetal. Just find it on the periodic table. Cl, nonmetal. Ti, metal. Sb, metalloid. Okay, so we don't have our fancy colored chart here, but Sb is right here and it's touching that line, and it's not aluminum. Sb is antimony, it's a metalloid. We can also divide up the periodic table in another way. We talk about the main group elements and the transition elements. And so these sections here in yellow, these two columns stick up, and these columns over here stick up above this section. This group, this part over here, and this part here together are considered the main group elements. The main group elements are generally more predictable in their properties. The transition elements are like the transition, they're transitioning between this side and that side, and their properties tend to be more hard to predict. Those are called the transition elements, or sometimes the transition metals, because they're all metals. Some of these, some of the columns in the periodic table have special names. So a column is a group, we call it a group or a family. So we'll talk about element groups or element families. And I like the word family because in a family, well, look at the clock.
Yeah, the clock's going crazy right now.
Maybe they're fixing it. Wow, it's almost 11:30. Those clocks are controlled somewhere else. Most of the time it's great, and then you have times like this. Families, we were talking about families. So in a family, you have individual people. And those people are not identical to each other. They have their own opinions, they may look a little different, but they do have some common characteristics as well. If you look at my kids, I've got cookie cutter children. It's like you use the same cookie cutter and went bang, 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 bang. Then you bake the cookies. They bake a little bit differently. So this one's a little bit lighter, and that one's a little darker, and this one's a little bit pudgy, and this one's a little taller. But you look at them and you're like, that's a Caligula. You can just see it. And yet they're very different as well. I could go on and on about that. I wonder if it's going to stop at the right time. Now it's 3:15. It's 3:30. No, shoot. Oh, man. So close. What? Now it's 3:40. Clock says 3:47. I'm going to zip it. Families. Okay, so these columns. What's special about these columns in the periodic table? Well, this column has a number, is group 1A, and it has a special name. We call these guys the alkali metals. And the metals in this are going to have something in common. I forgot to talk about hydrogen. Hydrogen's over here on the metal side of this line, isn't it? Is hydrogen a metal? No. Hydrogen is the baby brother of the element family. Baby brothers break the rules and get away with it, don't they? Yeah, we've got one of those at home. Baby brother gets to stay up with mom and dad and watch Psych when the other kids have to go to bed because baby brother took a nap at daycare and he will not go to sleep before 11, no matter what you do. So why fight with him, right? So hydrogen is over there. We're going to find over and over again that hydrogen breaks the rules. So just ignore him for now. He's his pesky little brother. The rest of these guys, these are the alkali metals, group 1A. They have common characteristics. Group 2A, these are called the alkaline earth metals. You should know the names of these families. Thankfully, there's only 4 of them. So over here, group 7A has a special name. These are called the halogens. And group 8A, these are called the noble gases. So now your book, I don't know why they just got these slides are kind of pointless. I need to edit this. I mean, there's a couple of nice pictures, but there's really no good information on this slide. I think, if I remember correctly, in your book, they talk about some of the characteristics. The alkali metals are all very reactive. They react with water. This is a picture of what happens when you put sodium metal in water. It reacts violently with the water. It generates hydrogen gas, and it generates so much heat that the hydrogen gas burns. So that's always fun. These are the alkaline earth metals, and they're going to have some common characteristics. We'll learn more about that. These are the halogens, and these are the noble gases. The noble gases, the nobles of Europe, who are those? Those are the kings and the queens, right, and the princesses. And they don't associate with the common people, right? So the noble gases are noble. They're above associating with the other elements. We now know that there are a few compounds that these noble gases will form, but generally they don't form compounds at all. They're remarkably unreactive. And so that's one of the common things that they have. So, to which group or family of elements does each element belong? So let's give the number of the group and its name if it has a special name. So lithium, what group is it in? It's in group 1 or group 1A. Does that one have a name? Yeah, those are the alkali metals. And those names, have historical meaning as well. B is boron. What group is that in? It's in group 3A. Now, these periodic tables that we have on the wall have a slightly different numbering on them, right? They're just numbered from left to right, 1 through 18. On the periodic table I will give you on an exam, boron is in group, I think the way it says it, let's just erase it. It'll say 13/3A. This is the current US usage, and this is the IUPAC usage, or what the International Union of Pure and Applied Chemistry has decided that they should be numbered as. I say we are currently in the US, let's use the current US usage. I like this numbering for the groups better because it gives us a little more information. Now these periodic tables don't have that, but what do you see in common between the number 3 and the number 13? The second, the ones place is the same number, isn't it? So group 13 is 3A, group 14 is 4A, group 18 is 8A. So it's not that horrible. That group does not have a special name. What group is I in? It's in group 7A. Does that group have a name? Those are the halogens. And how about AR? That's in group 8A, and those guys are called the noble gases. And sometimes, you know, because these groups have similar characteristics, it's easier to say, well, the halogens do this, instead of naming off each individual one. All those Kawagoa kids, you know, they do that. They run around like crazy people. So it's useful to use their names. And we're going to stop here.